All right, let's take a look at this example. A particle moves along a straight line. Its velocity is given by this function. Find the net distance and the total distance traveled from 0 to 9. All right, so we'll just set this up. Of course, the net is easy to set up. It's the integral from 0 to 9 of t squared minus 8t plus 12 dt. And you just take the antiderivative, plug in the endpoints, and you're good. If we do that, we get 1/3 t cubed from 0 or minus 4t squared plus 12t. And we go from 0 to 9. Now, if you plug in the 9, right here, 9 cubed is 729 divided by 3 is 243. Let's see, the next one is 9 squared is 81 times 4 is 324. Then plus 9 times 12 is 108. So let's see, 243 minus 324 plus 108 gives me 27. All right, so that's the net distance. That's it. Now, if we want the total distance traveled, with that one, we've got to, there are two ways you can do this. They're equivalent to each other, but one's better for using a computer, one's better for doing it by hand. The total distance is just the integral from 0 to 9 of the absolute value of t squared minus 8t plus 12. Now, if you could just evaluate that easily, that would give you the answer. It turns out you can do that on the computer. I want to do this by hand, but when we're done, we'll come back and do this one on the computer and see how it works. So, but what we need to do is split where the velocity equals 0. So if I split this up, well, I need to figure out where to split it up. So the velocity equals 0. All right, this gives me t minus 2, t minus 6. So I'm going to split at 6 and 2. So now what I need is a function, or well, I need to calculate this. Well, let me just write this first. The total distance then, it's going to be the integral from 0 to 2 plus integral from 2 to 6 plus the integral from 6 to 9. Yeah, 9. Now, if we just did that right there, that would give us the net distance again. What we're going to do is any of these that wind up being negative, we're going to force them to be positive. So we're just going to change them to positive so that we have the distance and not necessarily distance in reverse. And adding those up will give us the total distance. So what we need here is we need to evaluate the antiderivative, which we found up here. This right here. I'm going to call that big F of t. We need to find big F of 2 minus big F of 0. Then big F of 6 minus big F of 2. Then big F of 9 minus big F of 6. And add all that stuff up. So I'm going to come over here and I'm going to just calculate big F at the places we need 0, 2, 6, and 9. And I'm going to use Desmos to do those calculations for me. Let's see. I've already got big F entered into Desmos. So I'm just going to use this to compute, let's see, F of 0, F of 2, F of 6, and f of 9. Let's see, what are those? F of 0 is 0. Big F of 2 is 10 2/3. Well, let's see, what is that? 3 to 30, is that 32 over 3? Yeah, 32 over 3. F of 6 is 0. And F of 9, we can barely see it there, but it's, well, I just deleted it. F of 9 is 27. All right. So when I come over here and do this, I get this first bit is 32 over 3. This one is going to be 0 minus 32 over 3. Just notice it's just this minus this minus this, and this minus this. And the last one is just going to be 27 minus 0. Yep, let me turn Desmos off so you can see that. So these three numbers we get are this. When you take the absolute values and add these guys up, what you get is 64 over 3 plus 27, which is 48.3 repeating, or 48 1/3 is 145 over 3. All right, let's check this. Let's check both of these using the Riemann sum calculator. All right, so what I'm going to put in here is my the velocity function, which was t squared. I've got to put it in with x, so this doesn't understand t. So x squared minus 8x plus 12. And when I do that, if we go from, we're supposed to go from 0 to 9, so let me change this to 9. And I've got 5,000 rectangles there. And notice this right here is right on 27. If I make this 50,000 rectangles, yeah, it gets a little better. But anyway, so that corroborates the answer of 27 for the net amount. And again, that's taking those two areas that are above the axis, adding those together, and then subtracting the area below. If we want to find the net distance, what we have to do is take the absolute value of this, then that reflects that bit up top, and it gives me 48.32. Now, we said the answer was 48 with repeating threes, and if I add some more rectangles to get rid of the error, we can see that it's getting pretty close. So that looks good. So anyway, that looks good for both of our answers, and I think we'll stop here.